These are slightly different than the ones that we did on Monday. We are not finding the square root of these numbers. We are finding the cubed root. And the way that we know we are finding the cubed root is because of that number inside right there. Okay? That is the cubed root. Now, I want you to be aware of some of our cubes. We're going to go up to 5. So 1 cubed is 1. 2 cubed. That means 2 times 2 times 2. What is 2 times 2 times 2? 8. Okay? Then I have 3 cubed, which is 3 times 3 times 3. 27. They get big very quickly. 4 cubed. 4 times 4 times 4. Good, 64. And 5 cubed is 5 times 5 times 5. Okay, and that's really, usually 4 is as high as we go. But I go ahead and throw 5 in there. It's not as natural to find a perfect cube factor. These are the perfect cubes right here. Okay? So it's a little bit more natural for us to find perfect square factors. It's much more difficult to find perfect cube factors. So what I want us to do is I'm going to solve these both ways. I'm going to use prime factorization, and I'm going to show you how to find a perfect cube factor. I would say when you're finding the cubed root of something, the better way to do it is prime factorization. Okay? Do you have your cubes written down? Can I erase those? Okay. So, the first method that we are going to talk about for finding the cubed root of 24 is using prime factorization. Okay? Prime factorization. That's going to be our first method. So what I'm going to do is I'm going to take my 24 and I am going to break it down into primes. We did a lot of that last chapter. So I know this was called a factor tree. Most of you remember the factor tree. So 24 breaks down to 3 times 8. 8 breaks down to 2 times 4. And 4 breaks down to 2 times 2. Okay? So my prime factorization of 24 is going to be 2 times 2 times 2 times 3. Okay? Now, look at this problem right here. Do you see this? The square root of 2 times 5 times 5? This is when we were finding the square root of 50. When I was trying to find the square root of 50, how many had to be inside the radical for me to pull one out when I was finding square roots? Okay, 2. Okay, so you see there I've got 5 times 5. In order for me to pull a 5 out and put it on the outside, I had to have 2 on the inside. And that's what happens when we're finding square roots. How many do you think have to be on the inside when we're finding cubed roots? 3. Okay? So I have 2 times 2 times 2. So I've got 3 on the inside. So I'm going to take that and I am going to write 1, 2 on the outside. Okay? So I have 3, the cubed root, and the 3 stays on the inside. So my final answer to this is 2 on the cubed root of 3. 2 on the cubed root of 3. Now, the second way that I can do this is finding perfect cube factors. That is harder than finding perfect square factors. Okay? Perfect cube factors. That's our second method. Now here, for the square root of 50, I could find the square root of 25 times 2. 25 is a perfect square factor. Okay, but I'm looking for perfect cube factors now, and those are harder. My perfect cube factor in 24 is 8. So I have the cubed root of 8 times 3. 8 times 3. 8 is the perfect cube factor. What is the cubed root of 8? Good. So the perfect cube of that, the cube of 8 is going to be 2. Good. So I'm going to put my 2 on the outside, and then I'm going to put my cubed root, and I've got 3 left on the inside. Okay? I will tell you, prime factorization typically is the better way to go when you're finding cubed roots. And we know we're finding cubed roots because of that 3 on that's on the outside. That's called our index. Okay? So now I want to do the cubed root of 54. So I am going to do the prime factorization of 54. 54 is 9 times 6. 9 breaks down to 3 times 3. 6 breaks down to 2 times 3. So my prime factorization of 54 is 2 times 3 times 3 times 3. Okay? This is prime factorization. What number shows up 3 times? 3. So I'm going to move that to the outside. So I'm going to have 3 on the cubed root of 2. Okay? That's solving it using prime factorization. We can also solve the very same one using perfect cube factors. The perfect cube inside of 54 is 27. Okay? 27 times what gives me 54? 2. 27 times 2. Okay, what's the cubed root of 27? 3. Okay, so finding perfect cube factors is more difficult. It is more difficult. Okay, now I'm going to find the cubed root of 108. What I want to do first is find the prime factorization of 108. Okay, I don't really know what goes into 108 except for 2. How do I know that 2 goes into it? Yes, it's even. Okay? So I'm going to start with 2 because I don't naturally see something greater than that. So when I divide 108 by 2, I get 54. And that is easier for me to manage. I know some factors of 54. So I'm going to write down 9 and 6. 9 is 3 and 3. 6 is 2 and 3. So my prime factorization for 108 is 2 times 2 and 3 times 3 times 3. Okay? I have a set of 3 3s. So I am going to put a 3 on the outside. What's left on the inside? 2 times 2, which is 4. So my final answer there is 3 on the cubed root of 4. Now, the larger the numbers, the more difficult it becomes to find perfect cube factors. Okay? Since we've got the cubed root of 3 on the outside, we might be able to identify that 108 is 27 times 4. Okay, we might be able to identify that. I think that's not easy. Okay, so always keep in mind how to do the prime factorization. We know that the cubed root of 27 is 3. So I have 3 on the cubed root of 4. Okay? So this is finding cubed roots, and you can do it by prime factorization, or you can do it by perfect cube factors. Okay? And oftentimes you will have to go back to the prime factorization of that. Okay? Okay, let's go to the next. What we are doing here is something called rationalizing the denominator. We are going to rationalize the denominator. Okay, I teach trig online, and this is one of the things that has come up in my trig class, is rationalizing the denominator. So I want you to look at this. For a square root, or for a fraction to be simplified completely, we can't have a square root sign in the denominator. Okay, that's just one of the math rules. So we have to do what's called rationalizing the denominator. So my first one right here, I've got the square root of 2 over the square root of 3. Okay, I just took the square root of 2/3 and I rewrote it. Square root of 2 over the square root of 3. It's that square root of 3 that I have to get rid of. Now, what am I multiplying by if I multiply by the square root of 3 over the square root of 3? What am I multiplying by? What's 2 over 2? What's 3 over 3? 4 over 4. So square root of 3 over the square root of 3 is 1. So when I multiply by the square root of 3 over the square root of 3, I am multiplying by 1, and I'm not changing the value. I'm not changing the value. Okay? So when I multiply square root of 2 times the square root of 3, I get square root of 6. Okay? Then in my denominator, I get the square root of 3 times the square root of 3. That's the square root of 9. And what's the square root of 9? 3. Okay? So my final answer here is the square root of 6 over 3. Now, do you see how this 6 is inside the radical? But this 3 is not inside the radical? That means you can't simplify the two of those. In order to simplify, they both have to be in or they both have to be out. You can't simplify when one's in and one's out. Okay? Okay. So now we've got the square root of 5 over the square root of 8. Square root of 5 over the square root of 8. Okay, so I am going to multiply by what's in my denominator. I'm going to multiply by the square root of 8 over the square root of 8. So in the numerator, I'm going to have the square root of 40. And in the denominator, I'm going to have the square root of 64. Now, the square root of 64 is 8. We know that. What about the square root of 40? Can that break down into a perfect square factor? Square root of 40. Okay, is 20 perfect? 20 is not perfect. There's no number that you can multiply times itself to get 20. Good job, though. Yes, 4 and 10. 4 and 10. Okay, so I'm going to have 4 times 10. What's the square root of 4? 2. So I have 2 on the square root of 10 over 8. Now, I want you to go back here to where we had the square root of 6 over positive 3. Okay, square root of 6 over positive 3. I have one on the inside and one on the outside. But I want you to look here. Do you see how this 2 is on the outside? And 8 is on the outside. They are both outside the square root. So I can simplify that because they're both outside. And that's going to be important on Friday when we talk about the quadratic formula. Okay? So the square root of 2 and 8, the number 2 goes into both of those. So I am left with my final answer being the square root of 10 over 4. The square root of 10 over 4. Okay? Can I go to the next slide? Okay. Now what we're going to do is we're going to multiply. Okay? We're going to do some multiplying. So there's 3 steps when we're multiplying. First thing that we're going to do is we're going to multiply the numbers that are outside the square root. Okay? Multiply the numbers that are outside the square root. That's the first thing that we're going to do. Then we are going to multiply the numbers that are inside the square root. Okay? Then the last thing that we're going to do is we are going to simplify if we can. We're going to simplify if we can. Okay? So, my first step says multiply the numbers outside of the square root. So I have a 2 and I have a 3 on the outside. What's 2 times 3? 6. Okay? Then I am going to multiply the numbers on the inside of the square root. So I have a 3 on the inside of the square root and I have a 5 on the inside of the square root. What is 3 times 5? 15. Okay? Now, to simplify, what I look at is this number right here. Can 15 be broken down into a perfect square factor? Is there any number inside of 15 that I can take the square root of? No. Okay? So my final answer here is 6 on the square root of 15. Okay? Now we're going to do 7 on the square root of 6 times 3 on the square root of 8. So I am going to multiply the 7 and I am going to multiply the 3. So I am multiplying the numbers outside the square root. 7 times 3 is 21. Okay, then I've got the square root of 6 times the square root of 8, and that's the square root of 48. So I have multiplied the numbers on the outside, I've multiplied the numbers on the inside, and now I've got to simplify. This is where students make mistakes. They think the greatest perfect square factor in 48 is 4. Okay? It is not 4. The biggest perfect square factor in 48 is 16. Okay? So I have 3 times 16. That's my biggest perfect square factor, is the 16. Okay? What's the square root of 16? 4. So I have 21 times 4 on the square root of 3. 21 times 4 is 84. Now, what do I do if I don't know that 48 breaks down to 3 times 16? Because a lot of people don't. A lot of people look at that 48 and they think the greatest perfect square is 4. And a lot of people will leave 48 as 2 on the square root of 12. Okay? So what can we do to make sure we get the biggest perfect square factor out of 48? Okay? So, and that's called prime factorization. That's what we're going to do, is we're going to do prime factorization. So for 48, I've got 6 times 8. 6 breaks down to 2 times 3. 8 breaks down to 2 times 4. And then I have 2 times 2. So if I do the prime factorization of 48, so I've got 21 on the outside. I have 2 times 2 times 2 times 2 times 3. Okay, so I'm going to leave my 21. Now, if I have a set of 2 2s, how many do I pull out? Okay, you're right. So here's a set of 2s. So I'm going to pull a 2 out for my first set of 2. Then I have another set of 2s. So I'm going to pull out another 2. So for each set of 2, I pull 1 out. So then I'm left with my 3. So I have 21 times 2, which is 42, times 2 more is 84. So if you aren't sure that you can get the biggest perfect square, don't hesitate to do prime factorization. Don't hesitate to do that. Prime factorization. Okay? Can I go to the next screen? Okay. I want us to look right here. We've got the square root of 3 on the outside of the parentheses, and then I've got the square root of 6 plus the square root of 12. This is very similar, and we would solve it the same way that we would, whoops. Okay, let's try that again. We would multiply or simplify this the same way we would something like this. So I've got 3 times x plus y. What would I do for 3 times x plus y? Distribute. So with square root of 3 times square root of 6 plus the square root of 12, I would just distribute. That's how I'm going to do that. So I am going to write this out so that you can see. So I've got square root of 3 times the square root of 6. The square root of 3 times the square root of 6 is the square root of 18. So I've done that part right there. Now I've got the square root of 3 times the square root of 12. Square root of 3 times the square root of 12 is the square root of 36. Okay? Can I break 18 down to a perfect square factor? Yes. 9 and 2. Good. So I have the square root of 9 times 2. Okay. What's the square root of 36? 6. Okay. So the square root of 9 is 3. So I have 3 on the square root of 2 plus 6. That is my final answer. I cannot go any further than that. This is the same idea and the same principle as 3x plus 6. Can I combine 3x plus 6? No. They are unlike terms. I can't do it. Okay, so 3 on the square root of 2 plus 6, they are unlike terms. Okay, we're going to do the next one the same way. So 2 on the square root of 2 times 4 on the square root of 3. 2 on the square root of 2 times 4 on the square root of 3 is going to leave me with 8 on the square root of 6. Okay, then I've got 2 on the square root of 2. Do you see that minus sign there? Be careful with that minus sign. So I have 2 on the square root of 2 times 5 on the square root of 6. That leaves me with 10 on the square root of 12. Now, I want to make sure that I've got everything simplified. So I look at what's inside the square root. Can the 6 be simplified anymore? No. Okay, so that just stays the same. 8 on the square root of 6. Can the 12 break down to a perfect square factor? Yes, what is it? Good, 4 times 3. What's the square root of 4? 2. So I have 8 on the square root of 6 minus 10 times 2. So I bring the square root of 4 outside. So I have 8 on the square root of 6 minus 20 on the square root of 3. Okay? Okay. One more thing with square roots. I have a binomial times a binomial. What do you think I do? FOIL. That is exactly right. I FOIL. So I have the square root of 3 times the square root of 2. That's the square root of 6. The square root of 3 times the square root of 6. That's the square root of 18. Square root of 5 times the square root of 2. That's the square root of 10. Square root of 5 times the square root of 6. And that is the square root of 30. Okay? Now I'm going to make sure that everything is simplified. So I look here first. Can the square root of 6 be simplified? No. Can the square root of 18? Yes. What does the square root of 18 break down to? 9 and 2. What's the square root of 9? 3. Okay? So I'm going to have the square root of 6 plus 3 on the square root of 2. Can square root of 10 simplify? Nope. What about square root of 30? What does square root of 30 break down to? It's got to be a perfect square factor. Okay, is 6 or 5 perfect? No. Okay, and if we're not sure, we're going to do a factor tree for 30. Okay, so 5 and 6, 2 and 3. So my prime factorization for 30 is 2 times 3 times 5. Does anything show up twice? No, so we don't have a perfect square to pull out of that. Okay? So our final answer is square root of 6 plus 3 on the square root of 2 plus square root of 10 plus square root of 30. Okay? Okay. Now, again, the things that I want you to focus on the most for Chapter 5 are the exponent rules from Monday and solving equations from today. Yes?
Are the exponent rules on campus?
They're what we went over on Monday. They're these rules right here. We wrote them all down on Monday and did some practice with them, but the video is on campus. Okay? Okay. And so those exponent rules are important, and then solving equations with radicals. Solving equations with radicals. You will see solving equations with radicals on your test and on your final. So there are 4 steps in solving equations with radicals. And a radical is that square root sign that we see right there. The first thing that we want to do is we want to make sure the square root sign is isolated. Isolate the square root to one side. Okay? You have to do that first. You have to make sure that that square root is alone on one side. Okay? You've got to do that. The second thing that you do is you square both sides. The inverse of the square root is squaring, raising it to the second power. Okay? So my second step is to square both sides. My third step is to solve. And my fourth step is to simplify. Simplifying is important to identify extraneous solutions. Simplifying is important to find out if we've got extraneous solutions. There may be solutions that don't work, and that doesn't mean you did anything wrong. You just have to throw them out. So you must check. I wrote simplify. I should have written check. Sorry about that. We have to check for extraneous solutions. Okay? We have to check. So, I've got the square root of 2x minus 5 equals 7. I have already isolated the square root to one side. I've already done that. Okay? The square root of 2x minus 5 is isolated. So my second step is to square both sides. Okay? So when I square 2x minus 5, okay, I want us to think about what happens if I've got the square root of 3 and I square that. If I've got the square root of 3 and I square it, that's the square root of 3 times the square root of 3, which is the square root of 9. And what is the square root of 9? 3. Okay, so when I square something with a radical, what I get in the end is what's inside the radical. So when I square the square root of 2x minus 5, what I end up with is 2x minus 5. Okay? What is 7 squared? 49. Okay, now I solve. So I'm going to add 5 to both sides. I get 2x equals 54. I divide by 2. And I get x is 27. Now, the important thing to do now is to check. We have to check it to make sure that x equals 27 is not extraneous. So I am going to check 27. So I'm going to have the square root of 2 times 27 minus 5 equals 7. 2 times 27 is 54. 54 minus 5 is 49. Is the square root of 49 7? So it works. So our final answer here is x equals 27. X equals 27. Can I go to the next one? Okay. Before we do this one, I want to discuss the difference between Oh dear. I'm not really sure. I think it brought all my stuff back from last class. Okay. Desmos is glitchy. I want you to think about the square root of 16, and I want you to think about x squared equals 16. Okay? The square root of 16 and x squared equals 16. Okay? When we are talking about the square root of 16, we are only talking about the positive. Okay? It's only our positive. So what is the square root of 16? 4. Okay? When I am talking about x squared equals 16, there are two numbers that squared can give me 16. What are those two numbers? Negative 4 and positive 4. So this is positive and negative 4. When it looks like x squared equals 16. But if I'm just taking the square root of 16, I'm only talking about the positive. So that's going to be important in this particular problem right here. Okay? Now, I've got the square root of 3a plus 4 equals negative 4. So I am going to square 3a plus 4, and I'm going to square negative 4. I'm going to square both sides. When I square the square root of 3a plus 4, I'm left with 3a plus 4. What's negative 4 squared? 16. Okay? Now I can solve. I subtract 4 from both sides. So I'm left with 3a equals 12. I divide by 3. And what's my a value? 4. Now, when I go back to check this, I'm checking the 4. I will have 3 times 4 plus 4. 3 times 4 is 12, plus 4 is 16. When I take the square root of 16, I get 4. Is that what I started with? No. Okay? So I have to throw this out. This is what we call an extraneous solution. So my answer to this is no solution. No solution. Can I go to the next one? Okay. Now I have the square root of 2t minus 4 equals t minus 2. Do I have my square root already isolated? Is it on one side? Yes. So now what I'm going to do is I'm going to square both sides. So I've got 2t minus 4 squared equals t minus 2 squared. So I'm left with 2t minus 4. And I've got to FOIL t minus 2. That's super important. T minus 2 times t minus 2. T times t is t squared. T times negative 2 is negative 2t. Negative 2 times t is negative 2t. Negative 2 times negative 2 is 4. So I have t squared minus 4t plus 4. Okay? Be sure you recognize when you get something like this that you have to FOIL it. The answer to that is not t squared plus 4. Okay? You've got to FOIL it. Okay? Now, because this is a quadratic, and because I've got the squared right there, I've got to set it equal to 0 and factor. That's how I solve this. Set equal to 0 and factor. So I am going to subtract 2t from both sides. So I'm subtracting 2t, and I'm adding 4 to both sides. So I'm subtracting 2t, and I'm adding 4. So I'm left with 0 equals t squared minus 6t plus 8. Can that be factored? Yes, it can. It factors nicely. T minus 4 and t minus 2. Because negative 4 times negative 2 gives me positive 8. Negative 4 plus negative 2 gives me negative 6. So then I set each one equal to 0. And I get t equals 4 and t equals 2. But we must check. We must check. So I am going to check the 4 first. So I'm going to say the square root of 2 times 4 minus 4 equals 4 minus 2. 2 times 4 is 8 minus 4 is 4. So I have the square root of 4 equals 4 minus 2. Does it work? Yes. Okay, so 4 works. Now I'm going to check the number 2. Check the number 2. I'm going to have the square root of 2 times 2 minus 4 equals 2 minus 2. 2 times 2 is 4, minus 4 is 0. So I have the square root of 0 equals 0. Am I allowed to take the square root of 0? What is the square root of 0? 0. You are allowed to take the square root of 0. You're not allowed to take the square root of a negative number. You are allowed to take the square root of 0. Okay? So both of these work. So your final answer to this one are both of them. T equals 4 and t equals 2. Okay? I've got one more for us. Are we ready? Okay. The square root of x plus 6 equals x. Now, what's different about this one? The 6 is outside the square root. We must move the 6. Okay? We've got to get it on the other side. How am I going to do that? Subtract 6 from both sides. Okay? So I'm going to subtract 6 from both sides. Then I'm left with the square root of x equals x minus 6. Okay? What do I do now? Excellent. Square both sides. Okay? So I'm left with x equals, now I've got to FOIL x minus 6. Okay, x minus 6 squared is x minus 6 times x minus 6. Don't forget to FOIL. Students forget that they have to FOIL that. So I've got x squared minus 6x plus 36. So x squared minus 12x plus 36. Okay? This is a quadratic. How do I know it's a quadratic? Because of x squared. Good. So I've got to set it equal to 0. So I'm going to subtract x from both sides. 0 equals x squared minus 13x plus 36. This also factors nicely. Okay, I need two numbers multiplied. Say it again. Almost. Negative 9 and negative 4. Okay, so I have x minus 9 and x minus 4. Because negative 9 times negative 4 gives me positive 36. Negative 9 plus negative 4 gives me negative 13. Okay, I'm going to set each one equal to 0. And I get x equals 9 and x equals 4. I'm not done. What do I have to do? Check. Okay, and if I get an extraneous solution, it does not mean I did anything wrong. Just means I have to throw it out. So I've got the square root of 9 plus 6 equals 9. Square root of 9 is 3. 3 plus 6 is 9. So that works. 9 works. Okay, now I need to check the 4. I have the square root of 4 plus 6 equals 4. The square root of 4 is 2 plus 6. Does that one work? No. So I've got to throw that one out. And this is my only answer. Okay? Solving those equations is the important, one of the two really important things with Chapter 5. Make sure you understand the exponents and make sure you understand how to solve these equations. We are going to start on Friday with quadratics. We start on Friday with quadratics. I will see you guys soon.